All right, chapter 9.2. This is basically going to be the opposite of what we did in 9.1, which in chapter 9.1 we found the future value of a deposit or loan or etc. or something. Here we're going to define the present value. So the point of this is, let's say I want to have such amount of money saved up by a certain amount of time. How much should I invest now? So that's, I guess, what spurs this question, what spurs this section in the chapter. And so let's talk about it. Present value, again, to reiterate, how much should you be willing to pay for the right to receive a specified amount of money at a specific time in the future? This is the opposite of what we did in 9.1, as previously stated. The term present value is usually used to indicate the amount you should be willing to pay to receive a certain payment at a specific time in the future. The present value of an amount A is said to be paid after M periods of time with an interest rate of K per period is the principal P. I lost my train of thought there. Let's get into our present value formula. Now this is derived, and I don't know why it says M. When the last chapter used N instead of M. However, the textbook that I based this off of used M. So whatever that's for, we'll probably just change it to N in class. But the compound interest formula that we had in the previous chapter was your future value, which is A, equal to P, which is the principal, which is also kind of referred to as the present value as well, I guess. 1 plus K to the N power. Now, essentially, if we want to know the present value, think of it in an algebraic sort of way. You can divide by all of this junk to cancel it out and put it onto this side. 1 plus K to the N power, which is essentially where you get the formula that's here. It's just isolating the P value, the present value or principal amount. So it's not too far-fetched from what we were doing in chapter 1. Like I said, it's the opposite or section 1, the opposite of what we did in section 1. So find the present value of $100 to be paid in 5 years if the interest rate is 6% per year compounded semi-annually. So note the fact that $100 is what we want to have in 5 years. That's not what we're investing now. It's in 5 years I want to be able to get back $100. So my present value, as we look at the formula, is our future value, A, which is $100 here. Well, let me write the formula down, and then we'll plug in the numbers. 1 plus K. I'm just going to use N because that's what we did in section 1. So A is our future value. It's $100. K is our rate per unit of time. So that's 6%. 6% is 0.06. Now it's compounded semi-annually, which is twice a year. So K is going to be 0.0652, which is 0.03. And then N is how many periods. So if it's semi-annually, which means twice a year for 5 years, 2 times a year for 5 years, it's going to be a total of 10 times. So simple as that. You sort of just plug that in, get a number. I believe that comes out to $74.41. So this is how much money we need to invest now if we want to make sure we get $100 in 5 years at this rate. So it's very simple. Example 2, suppose a person borrows money for 6 months at an annual rate of 10%. If he must pay back $3,000 in 6 months, and if this amount includes both principal and interest, how much does he receive at the beginning of the 6-month period? All right. So hold on. Let me read that back. I got sidetracked. Suppose a person borrows money for 6 months at an annual rate of 10%. Yeah. If you must pay back $3,000 in 6 months, and if this amount includes both principal and interest, how much does he receive at the beginning of the 6-month period? So very similar. We're going with our formula. Our present value equals our future value divided by the 1 plus k to the n power. So our future value is 3,000. So we're going to plug that in for A. 3,000 is how much we're going to have to pay back in 6 months. Divided by the 1 plus k. So k, we got 10% interest, so it's 0.1. You can write 0.10 if that helps, but 0.1. And it's compounded, I'm assuming, semi-annually, since it says since it's going on 6 months. So that's going to be divided by 2, which makes the k value 0.05. Now, n is interesting because it's only going for 6 months. If it was going for a year, it would be compounded, once every 6 months, would have been twice a year. But this is only going for 6 months, and that's it. So it's only going to get compounded once. So there's your formula. You plug everything in. You got bada bing, bada boom. You get $2,857.14. Again, rather straightforward if you ask me. Moving straight on, let's try another one, see if this is any trickier. So the Homestake Construction Company owes the Fourth Federal Bank $10,000 payable in 4 years and $20,000 payable in 6 years. The company asked the bank corporate finance to consolidate the loans into one loan due in 5 years. If interest is 12% compounded semi-annually, what should be the amount due after 5 years? All right. So this one's a little trickier because we have basically 2 loans that we're combining into one, and we're changing the timetable on both of them. All right. What we're going to do is let me see, hold on what this says. One method of solving this problem is to compute the combined present values of the 2 loans and then to consider the amount will be in 5 years if invested at 12% compounded semi-annually. Oh, that makes perfect sense. So we're going to find the future value of both of these, or I guess the present value rather, of both of these loans, and we're going to combine them together at the end. So the present value of the first loan. Let's talk about this, the loan that we're going to have to pay $10,000 on. Using our formula, remember, which is A divided by the 1 plus k to the n power. Of course, A, our future value, is that $10,000. And then over the 1 plus k. K is going to be, for that loan, they're both 12%, right? 12% compounded semi-annually. So that's going to be 0.12 divided by 2, which makes 0.06 as the k value. Now, if it's payable in 4 years, it's compounded semi-annually, so that's twice a year, then that's going to be a total of 8 times being compounded. So this equates to $6,274.12. Now, what I'm going to do is I'm going to put that number off to the side because I'm going to need it a little later. So $6,274.12. But now we're going to do the same thing to find the present value of the other loan. So the other loan was $20,000. That's going to be due. Same interest rate, 12% compound semi-annually, so it's still going to be 0.06. But this one, if it's for 6 years, twice a year, that's going to be 12 times compounded. Now this comes out to be $9,939.39. Is that right? Yeah, okay. So now the present value of both loans is, if you combine these two values together, the present value of both loans is $16,213.51. So that's a present value of both loans if we kept them the way they were originally intended before consolidating them. Now, this is not our answer. Okay, but that's something we can use to help us find their answer. To finish this problem, to actually get our real answer, let's find out what the future value of this loan would be if we do it at what it suggested, which is 12% compounded semi-annually for 5 years. So this is going to be Now we have the p-value. Now we're actually going to find the future value that we'll have to pay out. Because it does say at the very end of this problem, what should be the amount due after 5 years? So it's asking for the future value. But we used present value to get there. So our future value is going to be the present value of our two loans, which is $16,213 and 51 cents, times, of course, 1 plus k to the n power. K is going to be the same thing, 0.06. N is going to be, if it's for 5 years, again, twice a year, the n is going to be 10. And you work that out, and you get the amount that's going to be due in 5 years if you consolidate both loans, which comes out to be $29,035.93. So let me backtrack a little bit to explain what we did, okay? Because it was a little bit kind of a jumbled mess. We had two loans, and we know the payable amount for both of those loans, which would have been, if we kept it the way it was, of course, $30,000. But we asked to consolidate the loans into just one and to do it in 5 years. So what we did was we found the present value. What is today's value of this loan and today's value of this loan? So we found both present values. That was the 6,274 and the, what was the other one? The 9,939.39. So this is how much we would need for this loan today, and then the 9,001 was how much we need for this loan today. Now, if we needed that much money today, well, if we consolidate it, right, and we change this account to a 5-year account, then we're using our compound interest formula to find that future value. This is how much the loan we need for the loan today, and then this is changing it to, of course, finding its value in 5 years.